So the main reason I studied petroleum engineering in university was because it involved the mix of the intangibles with the tangibles. So unlike other engineering disciplines, what's so challenging about petroleum engineering and actually oil and gas development as a whole is the fact that we have to rely upon all sorts of information of things that are miles down beneath the earth without actually touching it. And then we act on those pieces of information, and ultimately we create, the production that we see happening today. This takes me back to the start of my career. So 27 years ago, I sat out on an offshore platform in the Gulf of Mexico. And those of you who worked offshore before recognize that there's a lot of time that we're sitting there waiting for your turn at the wellhead. And as I was sitting there waiting for our turn to do a sand control treatment on a well, and this is the very beginning of my career, very first well I went on, an engineer 10 years my senior told me about all the technology advances that had come during his career and all the things that he had seen and all how those technologies have really helped to deliver better well performance, allowed us to do things quicker, safer, and so on. And he proceeded to tell me that he felt that there were so many technologies that had come in the previous 10 years that we were plateauing out on the technologies, and that the development of new innovation was going to slow. Well, I can tell you, 27 years later, what we're doing today is nothing like what we did when I started my career. So as an example, I'd like to talk a little bit about the unconventionals, because that has really been the next leap in oil and gas development. Those of you who are familiar with the resource triangle recognize that the sand control job that I was doing on that well in the Gulf of Mexico was some of that higher tier reservoir rock, high permeability, good flow rates, and so on, and your main challenge was to keeping the formation from being produced. Today, we're working at the bottom of that resource triangle. We're working in the very, very tight rock. The rock has a lot of resource base, but unfortunately takes a lot of effort to go and develop. So as an example of that, I'd like to take you to Powder River Basin in Wyoming. And so this is the plan for 18 wells in a small portion of the Powder River Basin. And in this, the single operator going to work this area. They plan on drilling 18 wells. And those 18 wells will be horizontal into the same horizon. And this is the data that's available via their permitting process. So you can see what the basic trajectories of the wells will be and how they'll develop that looking at a map view. But focusing in to what that looks like below the surface, this particular operator decided we're going to do this off of 5 separate locations. So those 5 locations will be about 15 acres worth of surface disturbance to do that. When they start doing that development, it will take them approximately 1 year with 1 drilling rig to drill each one of those wells, to drill all the wells in that play. And in that, they're going to end up covering quite a bit of that acreage. It's about 12 square miles worth of surface area that they'll drill. And it'll be 1 rig drilling off those 5 different locations, most likely. And when they're done, they're going to start the stimulation process. And when they come in to stimulate those wells, they'll likely do them on a pad. So in other words, there'll be multiple wells on a given location, and each one of those wells will get their own sets of stimulations. And it'll probably be somewhere around 30 or 40 hydraulic fracturing treatments per well bore in order to stimulate that. Now, when all is said and done, each one of those wells is going to have a surface area in contact with the reservoir rock of about 5 million square feet worth of rock that you physically touch, and that's what we're going to be producing from. Now, it's going to take the development of this whole play, again, it'll take approximately 1 year to do for this particular area. But I'd like you to keep in mind about what would happen if the modern technology was not available. And the technologies I'm talking about are things like reservoir characterization, the ability to go and directionally drill that well bore and stay within the sweet spot of a formation as you're drilling across it, and drill for very long distances. Now, drilling for long distances, especially in this part of the world, is nothing new. But early on in the unconventionals, you could not drill horizontal wells onshore. It was just not economic. But today it is. The next challenge that the industry had to overcome was the ability to run casing all the way to bottom, successfully cement it, and then be able to go and selectively open up sections of that wellbore and stimulate that section of the wellbore and move right on up to complete the whole well. That's not a trivial task, and it's taken a lot of development to happen in order to make that work. We've seen over the last decade or so a tremendous change in the amount of length that we can go and drill in horizontal. The first horizontal wells onshore were somewhere around 2,000 feet. Today, the technical limit is somewhere around 10,000 feet. And in some places, it's being constrained by not the technology, but actually by the political boundaries, in other words, the leasing rights that our customers have. So their acreage literally stops here. Otherwise, we could drill further. So a lot of technologies have made this happen. Now, the other thing, the last point I'd like to make before I go ahead and finish my discussion, is to consider what would happen if these technologies weren't available. To create that type of surface area in this reservoir, you would need over 500 vertical wells. 500 vertical wells as opposed to 18 horizontal wells. From a risk standpoint, think about what that means. 18 wellbores intersecting aquifers and so on and being properly cemented versus 500. Think about the time it takes to drill those wells. If you had to drill 500 vertical wells through here to develop this play and create this type of surface area, it would take six rigs 1 year to do that, as opposed to 1 rig to drill 18 wells. So it's through the combination of innovation and technology that we've allowed ourselves to ultimately reduce our footprint and make it to where we can do more with less and have a lower impact. Last point. It goes to how we interact with folks who don't understand what's going on below the surface. So that's not a trivial task. It is tough to go and describe to people who don't understand the reservoir rock that the hydrocarbons we're producing don't exist in just caverns and pools below the surface, but they exist in rock with extremely low permeability. And there's things that you need to do from an engineering perspective in order to make these things produce. As engineers, that's a new challenge, a new aspect of our careers that we have to learn, that we have to develop on how we interact with the folks that are not engineers. They are highly educated, they're curious, and they're concerned, and we have to be able to communicate with them about what we're doing and be very patient in making that happen. Now, the folks who are going to follow in my footsteps, the next generation of engineers who are coming into this industry, they will be able to tell you 20 years from now that what they're doing is nothing like what we're doing today. Thank you.